Okay, set operation. This is not really new to you. It's because we have learned page 84. We have learned this for many times. There are union, intersection, and complement. Union, intersection, and complement. So now 3.3, 3.4, 3.5. So remaining this chapter, it's all about the operations. Okay, it's all about the operations. So union, intersection, complement, okay, all about the operations. Okay, so make sure we understand the meaning of this. A union B means everybody, okay, so or, all the elements. Okay, A intersection, okay, A intersect B, okay, A intersect B is a common element. A complement means not in the elements. You see that? Not in the elements. That's how we define it. Now we want to make it into pictorial way of solving this. It's called Venn diagram. It's called Venn diagram. Operations, union, intersection, and complement. Okay, union, intersection, and complement. So when we study numbers, we have operations. Addition, subtraction, multiplication, division, those are operations. In set theory, operations are union, intersection, complement. Okay, union, intersection, complement. Venn diagram is a graph of set. Okay, so here is a notation. Universal set, okay, it's important. Universal set always denoted by box, universal set. Subset, it's always denoted by circle. So I have set A. Do you understand this? Okay, so universal set denoted by box, circle denoted by set A. So here's one thing. If I want to find the region, I want to find the region where A complement is. So A is any number in this circle. A is any number in this circle. A complement means anybody outside of this circle is A complement. That's what it meant. Do you understand this? Outside of this circle. Suppose I have a universal set U. I have two subsets. Here's a set A. Here's a set B. I have a partial overlapping here. Partial overlapping in here. I'm looking for A union B. Everybody in these two circles. A union B. Okay. I have a universal set U. I have a circle A, circle B. Here's a set A, here's a set B. I'm looking for common elements, partial overlapping right here. This is the intersection. Okay. So that's how we defined union and intersection. Are we okay with this? And then we need to practice with this, the regions. Okay. All right. So let me erase this. And I want you to practice. So you see that bottom of the page is the half of the page is definition. Half of the page is all about the Venn diagram. So I want to look at this. Okay, make it big on this Venn diagram. Assume first circle is A, second circle is B. Okay, so I assume the first one is A, so let's denote it as A. This is denoted as B. All like this, okay? Denoted as AB, 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 and AB, and AB. Okay. I give you a few minutes. Try it, okay? Whether you have a correct answer or not. Just the question of how much do you understand with the union, intersection, and complement. Just the shaded region, okay? So shaded is these regions. Okay, so can you shade it? Set A complement, A union B, A intersect with B, A union B of complement, A intersect B of complement. So I give you a minute and think what can be set A. So set A, the region of set A, shaded. region of set A complement, shaded, and so on. So go ahead and see how much you understand. This is the logic idea of that. Okay, so let's do this together. So I'm looking at set A. Set A is the circle. This is the circle, set A. So I want to darken that part. So anything in set A, I'll mark that. That's set A. Okay, that circle is set A. Are we okay with this? The next one is A complement. So A complement means anything other than the circle. So outside of this circle. So here's a circle. I want to mark anything outside of the circle. Okay, anything. So here is A outside of this. Anybody outside of this circle. Outside of this, doesn't matter. Any circles there. Anything outside of that. That's A complement. Question. Okay, so A complement outside of A. Okay, not in A. A union B. A union B is everybody in A, everybody in B. So everybody in two circles. So I denote this two circles right here. Like that. Okay, everybody in A union B. A intersect B, intersection, we are looking for common elements. As you see, here's a one circle, here's another circle, they're partially overlapped. So that partially overlapping area is intersection. Any questions so far?
Just so you know, the Jamboard is a little behind when you're like what you're talking, like the A union just showed up for me.
Okay, so it goes slow. So I don't know. This morning, maybe it's because of windy. It's not that windy, and
Yeah, I just wanted to let you know.
Okay, all right. Okay, so it's A intersect B. We all get that A intersect B so far. Okay. Okay, so let's have the next one. A union B and then complement. A union B and then complement. So A union B. This is A union B. Everybody in A union B. Complement A union B outside of these two circles. A union B complement. A intersect B complement. A intersect B complement. As you see, this is A intersect B, not in that. So outside of that. Okay. Question? Okay. So since we get a little bit confusing in here, I want you to do, okay, I want to change this form here. I don't have a Venn diagram anymore, but let me see. If I change this question, okay, so instead of this, I'm going to remove this. Change this question. Instead of A, I ask you to find the B. I ask you to find the B complement. Can you do it? Okay, give you a minute. Try to circle to find the region. What's the B? What's B complement? Okay, so here's a B, here's A, here's a B, B complement. Complement is outside of B. Okay, complement is outside of B. Okay, set B. Where is the set B? Where is the B complement? Outside of the circle. Okay, so set B, let's do it together. Set B is set B IM circle that of the B part. This is set B. B complement is outside of that circle, whichever is. If there are other circles, don't worry about it. Okay, outside of that circle. Okay. Are we okay with this? Outside of that circle. All right, so let me just give one more example and then we move on. Now I have, here is a box. Here is a set A, set B, set C. Okay, so I have A, B, and C. Okay, I want you to mark what is A union C. Okay, what's A union C? So don't worry about any other circle. Okay, you are only looking at A, you're only looking at C. So everybody in A, everybody in C. So you kind of darken that, those two circles, okay? A union C, only look at A and C. So here is a set A, here is set C. Only look at those two circles, okay? Here's A, here's a C. Okay, so your B circle is invisible, okay? So here's A, here's a C. Everybody is in A and C. Like that. A union C. We only look at those two circles. Okay, let me give you another example. How about still 3 of those? Okay, so 1, 2, and 3. Here's the ABC. Okay, my question is, can you find B union C? B union C. So we circled all B, okay? All B and all C. It's not complement. I'm asking you to find the union. So union is everybody, B and C. So we circled B and C. B union C. B union C. Okay. Are we okay with this? Do we need another example or no, we are okay with this. Very good. All right, so we just have a little bit of a taste on this Venn diagram, and a few minutes later, we are going to construct the Venn diagram and read Venn diagram. That's for the next one. So meanwhile, let's look at this another term. It's called disjoint sets. Okay, disjoint sets. Let me see if I can make it bigger. Disjoint sets on page 85. If two sets intersection of two sets is empty set, meaning there's no common element. Okay, there's no common element. Okay, no common element. We call disjoint. Let's look at the example here. Set A is a set of all even integers. Set B is a set of all odd integers. Are they disjoint? Let's write it out. Okay, set A is a set of even integers, 2, 4, 6, 8, dot, 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 ellipsis. Set B is a set of all odd integers, 1, 3, 5, 7, 9, dot, dot, dot. This is the set, Rosser method. So the question is, A intersect B. Okay, what are the common elements of A and B? There's no common elements, right? Empty set. That implies disjoint. Okay, question? No question. All right, so I want to try the next example, example 311 then. Okay, example 311. Okay, here's another set. Okay, set A is a set of prime numbers. Set B is a set of all even integers. Okay, are they disjoint? Okay, same thing. We are taking this set A. Wyatt, what's set A?
But it would start with prime number is divisible by, what is a prime number again? I forget.
A prime number is a number can be divisible by one in itself, except one.
Okay. So one was one a prime number?
No, one is not prime, except one.
Oh, okay. So two. Wait, so is it all numbers? Is it with then three?
3, yeah.
4.
4 is not prime number. It's because 4 is divisible by 2. 2 is not number itself, right? So 4 is not prime number. 5 is a prime number.
Oh, okay.
6 is not prime number. It's 6 divisible by 2, 6 divisible by 3. 7 is a prime number.
Okay, I got it. Yeah.
8 is not prime number. 8 is divisible by 2, divisible by 4. 9
So
is not
not a prime number.
It's because 9 also divisible by 3. So
Yeah. Okay.
11, 13, 15 is not prime number. 17 is prime number. 19, 21 is not prime number. 23, so on and so forth.
So then,
Prime numbers.
since B is a set of all even numbers,
Mhm.
2 would be in that, which means it's not disjointed, right?
Right, it's not disjointed. Very good. So here 2 is the only even prime number. Okay, so A intersect with the B is equal to element 2 because 2 is here, 2 is here, so it's not disjoint. Okay, not disjoint. Any question of the definition of disjoint? Okay. All right, the next one is we are looking at the operation with the empty set. So empty set is important. Empty set, okay. Intersection, any set intersect with the empty set is empty set. Any set union with the empty set is the set itself. I think we went over quickly last time, but I want to make it sure we all understand this, okay? So intersection with the empty set is empty set because there is no common elements. And it's set, and then you want to find the union. So one element of the set, and there empty set, there's nothing, there's no element. So you can't really add together. So it's original one, okay? Original. Let's have a exercise. Intersection union. We need this, okay? Intersection union. Intersection means common element. Union means everybody, okay? Right here, problem 57. Problem 57. So I tried to make it big, so I only have a 4. You probably have 6 parts. So go ahead and try in your textbook or workbook rather. Go ahead and try and let's do it together. So first 3 questions are all about the intersection, and the next 3 questions are all about the union. I only can project this 4, and then I scroll up for the remaining 2, but you have a workbook. So go ahead and try problem 57, and let's do it together. Okay, so let's do it together. So first 3 parts, intersection. So the key point of this is how do you find intersection? Intersection in here, intersection in here. Intersection means common elements, okay? That means common elements. All right, let's begin with iterate. What are common elements of these 2 sets?
6, 7, 10. No, actually 7 and 10. Sorry.
10, right? 7 and 10. So those are common elements, intersection. Okay. Part 2, Dorothy, what's the common elements of these 2 sets?
There aren't any.
There are any, so empty set. So Dorothy, do you remember if intersection of 2 set is empty set, what do we call this set?
Disjoint.
Disjoint, excellent. All right, number 3, set 1, 3, 5 and intersect with the empty set. Kayla?
That was the only one that I didn't do out of all of them.
Okay, number 3, Leslie, intersection set 1, 3, 5 and an empty set. Is there any common elements between these 2 sets?
No.
No, so empty set. So it's disjoint. Okay, remember, any set intersect with empty set is empty set. Okay, don't forget this. Okay, so intersection with empty set is empty set. Okay, let's move to the union.
I'm sorry, I have a question. Do you have to write disjointed next to the empty set symbol? Or can you just
No,
write?
not always. No, I just write it. This is
Thank
double check. Yeah, sure. So you don't have to write it here, but it's, you know, this is not test. This is just study purposes. So not just one thing, we write it 2 things. So we learn 2 things in 1 question. What about it? You know, it's good. Okay, so number 4, union. Union means everybody, right? So union means everybody. So one set union to another set. Wyatt.
For number 4, the intersection is, or
Yeah.
it's 1, 3, 5, 6, 7, 10, 11.
Excellent. So we do not repeat the same thing twice. Very good. So we can continue to do 5 and 6. Any question on this exercise? No question. All right. So I want to move to the next one. What I want to do, I want to find the Cartan number of a union of sets. So you do know what's a Cartan number. Cartan number means number of elements of a given set, right? Number of elements of a given set. So I want to show you one thing before I move on. So go back to the previous page. I need a space. So here, suppose I have set A that is a given as a 1, 2, 3. Set B, I have 3, 4, 5, and 6. Okay, 3, 4, 5, and 6. I want to draw a Venn diagram. Okay, are you ready? Here's a set A. Here's a set B. So set A and set B. Okay, of course, universal set is somewhere out there. I'll make it big so you can understand it's better. All right, set A and set B. You know what? I can make it bigger. Make it big. Okay, so here is a universal set. Here's a set A. Here's a set B. Okay, so we know set A denote, this is the set A notation right here, and set B is the region of this set B. So I want to write all the elements set A in the circle of A and set B in the circle of a B. Okay, now as you see, this part is a partially overlapping. That means we're looking at the intersection of the 2 sets. Agree? So intersection of these 2 is a 3. So I first write it intersection. As you see, at this region, it's a partially A, also it's a partially B. So 3 is belong to A, 3 also is belong to B. That's what I meant. Okay, this is the important part. Are we okay with this? And then I go back to set A, it's already 3 is given. I write remaining elements. And then you look at set B, I already have element 3. I write remaining elements. Do you understand this? Remaining element. So here is a question. What is the cardinal number of A? How many elements in set A? There are 3. What is the cardinal number of a B? How many elements in set B? There are 4. Agree? There are 4. Now, A union B. A union B is the region of A union B. Everybody in A and B. That's A union B. Agree? That's A union B. How many are they? Question is, what's the cardinal number of A union B? Which is a 6. Now, here's a problem here. Element A has a 3, number of element has 4, B has a 4. So 3 plus 4 is a 7. But when you combine this together, union, I have a 6. So 3 plus 4 doesn't match with the 6. What happened? I lost 1. It's because of this guy. I do not count one element twice. Remember, no repetition. So we write it, okay, so number of elements of intersection is 1, right? It's because of this guy. So write it out as a union of 2 sets. So number of elements above A union B, that is number of elements in A plus number of elements in B. It's obvious, right? So everybody in A and B, and then we subtract in common elements. It's because we do not repeat. Okay, it's because we do not repeat. Notation, number of elements. So usually notated by n, but sometimes we denote it by f sub value, number of elements. F sub value, number of elements. Okay, minus f sub value, A and B. Notation, cardinal number. Okay, cardinal number. So we only count once. So right here, formula for cardinal number of union of 2 sets. You can memorize the formula, or we understand the idea of this. Okay, we understand the idea of this. Union of 2 sets, subtract, common elements, and see. All right, let's have this one. Number 312. 312, let's look at that. Set A contains 30 elements. I don't know what are they. Set B contains 18 elements. 6 elements in common. How many elements are in A union B? So number of elements of A union B, that is number of elements in A plus number of elements in B minus number of elements in both. I write it that way. A intersect B is both. A intersect B means both. Number of elements in A, number of elements in B, minus both elements. So we have 42. Question? Okay. Are we okay with this? Okay. And then I want to show you one more thing. Now it's a combination of the operation. Okay, so not just one operation. I want to combine more than one operations. So I want to put this on the side. Okay. Suppose we have universal set A. We have set B. You have A complement. You have a B complement. We know A union B, we know A intersect B. Okay, so we have those. remember our ultimate goal is to find A union B complement to the complement intersect with the C complement, things like that. So we have mixed operations with more elements, more subsets. Now my question is this. First mixed operation, A union B complement. Okay, A union B complement. We know what is A union B complement look like. A union B not. So go back to here. A union B, this is A union B, right? A union B. A union B, everybody in A, everybody in B, complement, it's outside of this. Do you understand this? Complement is outside of this. What we want to do, instead of a graph it, okay, we just want to find this. Instead of graph it, we just want to find this. So do you remember when we have algebra, 2xy cubed, what happened to this? You apply this cubed everybody. So it's exponent rule. Do you remember this? Same idea. This complement applied everywhere. So we write it 2 cubed, x cubed, and y cubed. Write it this way. Complement applied everywhere. Complement, 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 complement. So we write it as A complement, union complement, B complement. Do you understand this? So everybody applied. But what is a union complement? So in set theory, we only have 3 operations: union, intersection, complement. So the opposite of a union is intersection. Do you understand this? Next thing, we have A intersect with a B complement. Again, I apply this complement. So every time you have a parenthesis, and that complement is like exponent, it like apply everywhere. So A complement intersect complement, B complement. Okay, so opposite of intersection is union. This is out, union. Okay, this is what we called De Morgan's law. Okay, this is what we call De Morgan's law. All right, so let's have a example here. Next page. Okay, let's verify this. Universal set is A, B, C, D, E. Set B, set A has B, C. Set B has B, C, E. Find each of following sets, and we want to verify this. So let's first find this one. I want to separate it like this, okay? So A intersect B, okay? A intersect B. We are looking at common elements of these two. Common elements of these two is BC. A intersect B complement, meaning we are looking at complement of this. So you look at the universal set, complement of this. So B, C here. So left over A, D, and E is A intersect B complement. Okay, some of us write it A intersect B, that's B and C complement. So we do not confuse this. So we write it as A, D, and E, put extra step in there. That's fine. Okay, any question? No question. All right, let's do the next one. A complement, union, B complement. So A complement, element is not in A. B complement, element is not in B. And then union of those. Okay, so A complement first. So this is BC. A complement is A, D, and E. B complement, that is element BCE, BCE, I have AD. Okay. A complement union B complement, that is ADE union AD. Union means everybody, that is A, D, and E. You see that? Those two are matching. They are same thing. Complement. Okay, De Morgan's law. So opposite of union is intersection. Opposite of intersection is union. Okay, opposite of intersection is union. Opposite of union is intersection. All right, so let's try this one. Oops. Okay, any question? Okay, so on the bottom of the page, you have problem 59. Let me erase this. Okay, this is the first time ever we have set is given and given Venn diagram and answer the following questions like that. But when you turn the next page and a few pages like this, there are questions like that. Okay, there are questions like this, and the remaining chapter is all about this. So this is extremely important. And the Venn diagram with the mixed operation is on the quiz. Okay, it's quiz on Wednesday. We have a operation with the Venn diagram. Okay, and exam, midterm exam. We have one more exam around the Thanksgiving, and we have a final. When it's a final, mixed operation with the Venn diagram will be there. So this is that much important. This is a key point of a set theory. Okay, so this is a key point of set theory. So remaining today's lecture, same as Wednesday, and then maybe one more day of the set theory. We are going to do set theory with the set operation and the Venn diagram, mixed operation, and solve this Venn diagram. Okay, it's all about that. All right, so forget about the answer of this guy. I want you to try this first, okay? I show you quickly how to construct. Probably many of you don't get it. So this is a good exercise so we can practice. I want you to try. I give you 2 minutes, it's short time. And we are going to do together. Okay, the key point is you're taking overlapping area first, okay? So intersection, find the intersection first, then you move around, okay? Find the intersection first. Okay, so let's do it together. So some of us feel this is hard. So I first labeled, this is A, and that's B, and this is my universal set. So the first thing, you label that. The second, we are looking at the overlapping area of these two, meaning you look at set A and set B, I am finding, is there common element? Okay, so put this common element first. This is overlapping area, intersection of two sets. Right here, set A and set B. What are common elements of those two sets? It's 1, 2, and 4. That's what I see. Okay, and then I go to the next circle. So here's a set A. Set A. Set A is everybody in this circle, right? Everybody in this circle. We already have 1, 2, and 4. 3 is left over, so write it out. Set B is the circle of the right one, and set B is including 1, 2, and 4. So 1, 2, and 4, 5 is left. Are we okay with this? We are not done yet. It's because a universal set has to be determined in here, universal set right here. So set A, okay, set A is here, set B is here, and other than these members, so 1, 2, 3, 4, 5 is here, 6, 7, 8, 9, 10 is missing. So you put outside of that. Okay. Any question how to construct Venn diagram? Okay, now let's answer the following questions. Okay, I did not ask you to solve this. I just asked you to, okay, construct it. So now next thing is, when you look at this, A intersect with the B complement. Don't confuse with the A intersect B parentheses complement. They are not the same thing, okay? Parentheses complement means intersection and you take a complement. B complement only, okay? They are not equal. So make sure you don't get confused with this. Do you understand this? And if it is a mixed operation, and then don't get confused. We are doing sort of like a PEMDAS order, okay? Left to the right, inside of parentheses first, and then complement and things like that. You know what I mean? So take the order. So for this example here, A intersect with a B complement. So it's not clear. I first look at B complement. I first look at B complement. So you see this is a B. This is a B. So this is a B. B complement that is outside of the circle. B complement is outside of circle. So everybody outside of the circle is B complement. Okay, everybody outside of the circle is B complement. Do you understand this? Not just A, everybody outside of circle B is B complement. So they are 3, 6, 7, 8, 9, and 10. Okay. Any question how to find B complement? All right. So the question is A intersect with a B complement. I rewrite it, said A intersect with the B complement we just found. Okay. Intersection means common elements. So here's a 3, here's a 3. That's it. So it's a 3. Do you understand this? Try part 2. Okay, so I give you again 2 minutes. Find A complement, and then B, this time, union of those two sets. Okay, so let's first compute A complement, okay, A complement outside of the circle, A complement, outside of circle, A complement, other than A. So here's A, I'm looking for anybody outside of that circle is A complement, okay, A complement. Outside of this circle, A complement, outside of this circle is A complement. Okay, outside of that circle is A complement. Okay, outside of the circle is A complement. Okay, Leslie, what's A complement?
For A complement, I put 5, 6, 7, 8, 9, 10.
Very good. So we
And
have,
then I put for B 1, 2, 4, 5.
okay, hold on a second. So we write it 7, 8, 9, 10, union 1, 2, 4, 5.
And then the union is 5.
Union is everybody.
Well, the AC union B.
Okay, everybody inside here, union here. Union means everybody.
Yeah.
Everybody of the set, everybody of the set. That's a union. Okay, that's a union. Okay, Wyatt, what's the union of this?
5.
Union. Intersection is 5. I'm looking at union. That's what Leslie says. So I asked somebody else. Leslie said 5. 5 is intersection. So A complement B is a 5. That's what Leslie says. So that's fine. This is good. But I'm looking for union, everybody. You know what I mean?
Yeah,
Everybody.
so then it would be,
Okay. Michael, what do you think? Union, everybody. Okay.
I put 1, 2, 4, 5, 6, 7, 8, 9, 10. So just not 3.
Okay, everybody here. Do we understand this union and intersection? Yeah, okay, union and intersection. Okay. Now we are looking at 3 subsets. You ready? Okay, so I'm gonna move to the next one. We first, it has a long question. This is part A, B, C, 1 to 3. But I want to find this problem 60 on page 89. Construct the Venn diagram first, and then we move on. Okay, construct the Venn diagram first. So here is a Venn diagram, and I show you how to do with the 3 subsets. So it's more. Okay, so we are having 3 subsets throughout the semester. So not 2, but 3. So let me show you how to do this, and then I quickly erase so you can construct this. Okay, so here you go. You ready? The rule of constructing Venn diagram is you are starting with most overlapping area first and then expand it out. Meaning, as you see, there are 3 circles, circle 1, 2, 3. And as you see, it's like a triangle shape, like in the middle right here, triangular shape right here. This is the overlapping area of 3 circles. Agree? This is overlapping area of 3 circles. So let me give you a color marker so you can see it better. So this is a set A. And the set B, I use red. So sometimes it's easier to see with the color. And here it just says C. Okay. Like that. And you see right here, it is a partial green, blue, and red. So this is overlapping of all 3 subsets. Agree? All 3 subsets. So I want you to look at this guy first, and then intersection with the red and blue, and green and blue, and then green and red, and then go to blue, red, green, and then you look at universal set. That's the plan. Okay, so let's do it. All right, so let's first look at green, red, and blue, meaning intersection of all 3. Intersection of all 3. Okay, what are the elements intersection of all 3 sets? Is there an element, by the way? Is there an element intersect in all 3 sets? Yes. There's a 3.
Yes, I got 2 and 3.
2 and 3. Oh, 2 and 3. Okay. Right. Okay, 2 and 3. So far, so good. 2 and 3. And then I expand it out. Okay, so meaning I'm looking at blue and red. Forget about the green. Okay, blue and red. So this is a blue and red. Okay, forget about the green. Okay, blue and red. Meaning A and B, blue and red. What are the elements in common of A and B? Blue and red.
It's 1, 2, 3.
3, but we already have 2 and 3, so 1. We don't repeat. Next one, here is blue and the green. Okay, blue and the green right here. Blue and green, blue and green, blue and green. A and C, A and C. What are common elements of A and C? 2, 3, and 4. Here's a 4. Okay, next, green and the red, red and green, green and red, right here. Okay. This one. B and C. Common elements of B and C, 2, 3, and 6. 6 is missing. Okay. Any question? All right. And then I look at blue. Okay, so I take each spot here, blue. Okay. Set A. Set A has 1, 2, 3, 4, 5. 5 is missing. Set B, 1, 2, 3, 6, 8 is missing. Set C, 7 is missing. Okay, we're not done yet. Remember, this is a universal set. Any number missing from universal set, we have to write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9 is missing. Question? Okay, I want to erase this Venn diagram. Okay, I want you to reconstruct yourself of this Venn diagram and then following answers. Okay, so let me erase, quickly erase. Okay. We need to construct the Venn diagram. Okay, and answer the following questions. Okay, so there are 3 parts. So I give you another 5 minutes. Okay, I give you another 5 minutes. Okay, so this is a key concept for set operations with a Venn diagram. Okay, so it's extremely important. I want you to practice this, and let's do it together. So 5 minutes. Okay, so construct a Venn diagram from the scratch. And those of you are already finished this, okay, you move to the next one, problem 61. Okay, so there are many problems are following. Go ahead and try. Okay, so let's do it together. So we have a Venn diagram. So I go back to the Venn diagram. Here's ABC. Okay, common elements are 2, 3. And in set A and B, we have 1, 2, 3. And set A and C, we have 4. And the B and C, we have 6. 5 is missing, 8 is missing, 7 is missing, and then here's 9. So we construct this. Let's have the following answers here. So in order to do this, we do inside of parentheses first and then union of this. So inside of parentheses first, intersection of this. Inside of parentheses and the intersection. So that's the rule. Okay, parentheses first. So let's first look at B intersect with the C. So B intersect with the C. Intersection of a B and C. Intersection of a B and C is this. Intersection of B and C. Okay. So we have 2, 3, 6. Okay. Intersection of a B and C, 2, 3, and 6. A union. 1, 2, 3, 4, 5. Union 2, 3, 6. So union means everybody. 1, 2, 3, 4, 5, and 6. That's how we find. Okay. Let's look at A union B and A union C. So A union B. A union B. A union B. Everybody in A and B. Everybody in A and B. A union B. A union B. A union B. That is 1, 2, 3, 4, 5, 6, 8. A union C. Everybody in A and C. Everybody in A and C. Here is AC. Everybody in A and C. Everybody in A and C. A union C. 1, 2, 3, 4, 5, 6, 7. intersection of that means common elements. Okay. 1, 2, 3, 4, 5, and 6. Common elements. Question? Okay. The last one. B union C complement. Okay, B union C complement. So we first have to do complement, B union to it, and then intersect with the A. Okay, that's the plan. So C complement. C complement. Here's a C complement outside of C. Okay, outside of C. C complement. Outside of C. C complement. Outside of C is a C complement. So C complement is 1, 5, 8, and 9. C complement. B union C complement. B is 1, 2, 3, 6, 8. Union C complement 1, 5, 8, 9. Union means everybody. Union means everybody. 1, 2, 3, 5, 6, 8, and 9. A intersect. So A, 1, 2, 3, 4, 5 intersect with this. So 1, 2, 3, 5. So, okay, so that's the A. Okay, so this is, so we have a 1, 2, 3, and 5. That's the intersection. This is the answer. That's the answer. Okay. Question. It's hard, right? It's hard. It's not easy. I'm not saying this is easy stuff, but practice is the best way to understand the concept. So I want you to turn the next page, page 90, problem 61. Problem 61. Okay. So this time, I do not want to do anything from the beginning. I want you to do from the scratch. Okay. So here is a Venn diagram, and then you have your workbook. Here's a Venn diagram. There are part 1, 2, 3 questions. So go ahead. Okay, this is the last question for the day. Go ahead and see how much you can do with this. Okay, see how much you can do with this. Construct the Venn diagram and answer the question. Okay, so let's construct the Venn diagram first and see how much you do. Okay, so the first thing is we are looking at that overlapping area, like triangular area. Okay, so Italy, what number supposed to be put it in the middle?
Sure. 1, 2, 3.
No, right here. Meaning I'm looking for a common number of these 3 colored. Okay, so
Oh, never mind. It's 2 and 3.
2 and 3.
Yeah, 2 and 3, I believe.
2 and 3.
Yep.
Common elements of A, B, and C. Kayla,
I only got number 2.
you only got 2. You only got 2. Let's double check. So we have a 2 here, we have 2 here, we have 2 here. So 2 is only number. Italy, only 2, okay? So common elements of all 3 sets, only 2.
Oh, okay. I thought it was 3.
Let's look at A and B. So here is a red, and here's a blue. A and B. So common elements of A and B. Common elements of A and B. Leslie, common elements of A and B. Red and blue. A and B.
1, 1 and 4.
1 and 4. Okay, 1 and 4. Okay. Common element of this. Green and the blue, green and blue, common elements of these 2. Okay, 2 is already there, so 3.
3.
Okay, common element of green and blue, red here, B and C. Wyatt, B and C.
5.
5. Okay, then I'm looking at set A. Okay, set A, 1, 2, 3, 4, 1, 2, 3, 4. So there's nothing, so nothing to put. 1, 2, 3, 1, 2, 4, 5. Everybody's here. There's nothing. Okay, 2, 3, 5, 7. Okay. And that universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so those are outsiders. Okay, do we all have the same thing? The easiest answer of these three parts is this guy. A intersect B intersect C. What are common elements of A, B, and C?
It's just 2.
2 right here. Okay, just 2. Okay, let's do it backward. Number 2, A complement, B complement, C complement, and you take a union of those. Okay, so A complement, B complement, and C complement. A complement means outside of this blue circle. That's A complement, okay? Outside of a blue circle, outside of a blue circle, A complement. Outside of this blue circle, outside of this blue circle. Michael, what's A complement?
It's 3, 6, 7, 8, 9, 10. Or not 3, sorry. 5, 6, 7, 8, 9, 10.
Okay, 5, 6, 7, 8, 9, 10 is A complement. We all agree with that? Okay, B complement, outside of a red circle, outside of a red circle. So you have a red circle outside of that, okay? Outside of red circle. Dorothy, what's the B complement? Outside of red circle.
3, 7, 6, 8, 9, 10.
3, 7, 6, 8, 9, 10, okay? C complement, it's outside of a green circle, outside of a green circle. Jason.
It would be 1, 4, 6, 8, 9, 10.
9, 10. Very good. And I want to take a union of all these guys. It says union and the union. That is union of all these guys, meaning everybody in this whatever that is. Okay. So who can read this out for me? Leslie. Union. Okay. Everybody.
So it's 6, 7, 8, 9, 10.
Union, union, union. Leslie. Union. Everybody. You just read intersection. Union. Everybody.
So okay, so 3, 5, 6, 7, 8, 9, 10.
3, 5, 6. Okay. 7,
Well,
8.
you already put 10, so yeah, 3 and 5 were missing.
4 is missing. 1 is
Yes, 4 and 1.
okay, let's rewrite it. So is this really? Okay, let's write it in order. So this is the order doesn't matter, but we write in order, so make it easy. 1, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 7, 8, 9, 10. Now we just learned De Morgan's law. I don't know. Do you remember this? A intersect B intersect C, and you make a complement. That is A complement. Union complement is intersection. Okay. And then B complement, and then you see this intersection, then the union, C complement. Isn't this the same as that? So it's a lot easier to take a complement of the 2 to get this answer. Okay, De Morgan's law. This is exactly 2 and then complement. Okay. All right. We'll do this in class on Wednesday. Okay. So I want you to practice